Hey there, students. I want to show you what matrix inverses are. And so these inverses is really the equivalent of matrix division. And it is a process that we use to solve matrices. Now it's kind of involved, so I need you to take really good notes. But we have to begin by understanding what the identity matrix is. Now the identity is not the inverse. Identity matrix is called that because if you had something that's 1 is the identity of multiplication. If I have 1 times A, I have A. 1 times any number is that number, right? So this is the identity matrix. So they look like this. They're always going to be a 2 by 2, 3 by 3, 4 by 4. They're always going to be a square matrix. And it's only going to have 1s and 0s. And the way it works is if you start at the top left, the 1s are on a diagonal. So it's 1, 0, 0, 1. But notice my 1s are on a diagonal. On a 3 by 3, 1, 0, 0, 0, 1, 0, 0, 0, 1. So notice again, the 1s are on a diagonal, and that point continues ad nauseum for infinite number of matrices that are square. Those are the identity matrices. Now let me show you how they work. You know, we just finished multiplying these matrices, so let me multiply this matrix 2, 3, 4, 5 by an identity matrix. So the 2 times 1 is 2, 3 times 0 is 0, so that becomes a 2. 2 times 0, 0, plus 3, 4 plus 0, and then 0 plus 5. So notice that if I take a matrix, multiply it by identity, it becomes itself. And if I take the identity matrix and multiply it by this, look what happens. This becomes 2 and 0, 3 and 0, 0 and 4, 0 and 5, and what we have is this one. So what's really odd is this. So please make note of this. You can do that either way. Unlike general matrices, the identity matrix is commutative. So if you take any identity matrix, let me write that down. Okay, an identity matrix multiplied by matrix M is matrix M, and it's commutative. So let's close in the point. Why does it matter? Look, if you have 1 times M, you get M, right? So if you think converse of that, conversely speaking, that means if you have M times 1 over M, I'm just changing this first equation around, I get M over M, which is, by the way, 1. I get 1. So notice I have 1 over M, because that's what we're going to do. We're going to be working to get to a value that's that. So how do you get to this inverse? How do you get this 1 over M? You got to start by finding this thing called your determinant. The determinant is a value that you need to achieve the inverse. And the determinant of any matrix, in this case it's A, is equal to, and it looks like absolute value bars, but this means, when you see this, that means the determinant of matrix M. Here, where I have it around an A, that's the determinant of matrix A. And you do that with a square matrix. We're just going to do 2 by 2s right now and then do 3 by 3s. And to do that, you got to take A times D minus B times C. So you see the little fish here because I kind of use that. I always do this little swoop, A times D minus B times C, to help me to remember. And I always start at this top left, just the way the 1s start at the top left, and it helps me to remember. So let me show you what I mean. Let's do this one. If I work this one and I do 1 times negative 4, negative 1 times negative 4 is positive 4, right? So here's 4 minus 20, and 4 minus 20 is negative 16. So if they called this matrix B, I would go, okay, the determinant of matrix B is equal to negative 16. Let's call this C, and you try it without me. Okay, hopefully you've tried it, And here we go. I'm going to do 4 minus negative 25, and 4 minus negative 25 is equal to 29. So the way that you would express that is that determinant C is equal to 29. That's the determinant. Now, on a 3 by 3, look how complicated this is. I'll be showing you this because they take A, this first value, multiply it by that, then subtract the middle value by this little corner right here, and then C, oh no, wait, see, I'm already doing it wrong. This B times these things, and then C times this corner. It's a bear. I don't like it. I do this. So I'll be showing you how to do this by hand, which I really like this method because you can do it pretty fast. It looks a little complicated here, but I promise you I'll show you how to do it fast. 4 by 4, ain't no way. I'm not going to do a 4 by 4. Look at how complicated that is. I mean, it's A times this corner, and then B times you skip this row and do those 3, and then the C, and the B and D are negative, and then the C times this corner, and then the D, who cares? I mean, it's just too complicated. I wouldn't do it. But how do I calculate the inverse? Step 1, use my little fish to find the determinant. Step 2 is you put 1 over the determinant, and you multiply it by, you got to switch. This is going to drive you crazy. If you have this 2 by 2 of ABCD, you're going to have to change things. You put 1 over the determinant times A and D switch places. C and B do not, but they both become negative. I know. And then you multiply. You do a scalar multiplication. All right, so I'm going to do one for you. Here we go. Matrix M. Step 1, find the determinant. So, to determinant. I'm assuming you understand what I mean. So this is going to be negative 20 minus 14, which is negative 34. So this equals negative 34. Now, step 2, take 1 over the determinant times, and I'll put over here, I hope you understand what I'm doing with ABCD, D, A, negative B, negative C. Okay, so let's do that. I'm going to take 1 over 34, and it's negative, so I'm going to assign that to the top. And I'm going to multiply that by this. 4 and 5 are going to switch places. Negative 7, negative 2, and here we go. Negative, and I just keep everything over this determinant. I simplify later or I'll get angry. Okay, so this is going to be 5, 34, because I took negative 1 times negative 5, got positive 5 over 34, and then that's going to be 7 over 34. That's going to be 2 over 34. Not simplifying, not yet. And there is my inverse. There is my inverse. And I am hearing you say, so stinking what? Well, we're at 9 minutes, and I'll tell you what tomorrow. We're going to practice this. Take care.